Good morning, everyone. So, my name is Shekhar D, Senior Physics Faculty. Today, we are going to discuss about angle of repose and the acceleration of the block slides down along the inclined plane. At the same time, acceleration of the body slides up along the inclined plane. Next, acceleration of the body slides down along the smooth inclined plane, and the acceleration of the body moves up along the smooth inclined plane. So, now, here, first of all, angle of repose. Angle of repose means it is the angle of inclination. It is the angle of inclination of the inclined plane with the horizontal for which block just begins to slide down. Begins to slide down. So here, what is the angle of inclination? So first of all, we can now draw the one horizontal line. So like this is inclined plane. Inclined plane. So your inclined plane means the plane makes an angle theta with the horizontal. The plane makes an angle theta with the horizontal. That is known as inclined plane. Suppose here theta, your inclined plane coincides with the horizontal angle of inclination 0. If any block placed on the plane, there is no motion. So this angle of inclination gradually increases. At particular angle of inclination, the body begins to slide down. That angle of inclination is called angle of repose. Angle of repose. Angle of repose. Okay. So here, theta, angle of incline goes down toward the horizontal. Inclined plane decreases. If the angle of inclined plane moves up, so theta is increases. So at particular angle of theta or angle of inclination, the body just slides to down or begins to slide. That is known as angle of repose. So where angle of repose theta is equal to alpha. Theta is equal to alpha. Theta is equal to alpha. So now here block of the mass initially at this point, the weight of the body we know that always acts vertically downward direction. Now we draw the normal force. So that normal force 90 degrees to the surface. So normal force we can resolve in two components. Sorry, mg. Weight of the body resolving two components. Mg cos theta balanced by normal force. At the same time, mg sin theta acts downward direction along the inclined plane. The body begins to slide. The frictional force becomes to limiting friction. The frictional force becomes to limiting friction. Limiting friction. From figure, limiting frictional force balanced by mg sin theta. Mg sin theta. So, where angle of inclination theta becomes to alpha, that means alpha. Let be equation 1 begins to slide. Theta taken as alpha. N is equal to mg cos alpha, equation 2. Now, equation 1 divided by equation 2. Equation 1 divided by equation 2. FL by N is equal mg sin alpha by mg cos alpha. So here mg get cancelled. So remaining FL by N is equal to sin alpha by cos alpha. It is written as tan alpha. But FL by N, we know that Vs tan alpha. So FL by N, we know that tan alpha. Like where Vs is equal to coefficient of static friction. Where Vs is equal to coefficient of static friction. Therefore, angle of repose numerically equal to coefficient of static friction. Coefficient of static friction. So already we know that in previous case, angle of friction also. Now you should remember Vs is equal tan alpha is equal tan phi. This is already we know that in previous conditions, tan alpha numerical equal to Vs. So your angle of repose equal to Vs. Vs is equal to tan phi. So this is angle of repose. The relation between angle of repose and coefficient of static friction. Vs is equal to tan alpha. So where angle of repose, the body is ready to slides. Theta becomes to alpha. Theta becomes to alpha. Where theta is equal to alpha, body not slides. So begins to slides down. So that is static friction of force converted to limiting friction, FL. Limiting friction. Next, acceleration of the body. Acceleration of the block. Slides down along rough inclined plane. So another concept, acceleration. To find the acceleration of the block, slides down along the rough inclined plane. So if the body moves on horizontal surface, F is equal to ma, a is equal to f by m. Your body slides down along the rough inclined plane and find the acceleration. Acceleration. So now consider rough inclined plane. A plane makes an angle theta with horizontal. So like this is height of the inclined plane. Now consider a block of mass here. So weight we know that always vertically downward direction. Normal 90 degrees to the surface. So your weight of the body resolved into two components. Mg cos theta. The same time mg sin theta. Mg sin theta acts along the perpendicular and downward direction. Now your condition theta is less than alpha. Body does not slide. If theta is equal to alpha, body mean block ready to slides down. Ready to slides down, where theta is equal to alpha. That means frictional force, static frictional force becomes to limiting frictional force. If theta is greater than alpha, block slides down with the acceleration where theta greater than alpha. Theta greater than alpha means, so this frictional force, limiting frictional force becomes 2. Limiting frictional force becomes 2. Kinetic friction. Limiting frictional force becomes to kinetic friction. So your body slides down mean mg sin theta greater than 2 frictional force. So that means resultant force F downward direction. F downward direction along the inclined plane. Now, according to Newton's second law of motion, net force acts on the block. F is equal to mg sin theta minus Fk. Mg sin theta minus Fk. But Fr is equal to Ma. Mg sin theta. But Fk is equal to, we can written as Vkn. Vkn. F is equal to Vn. From diagram n is equal to how much, or from figure n is equal to mg cos theta. N is equal to how much? Mg cos theta. So therefore, Ma is equal to mg sin theta minus Vk n into mg cos theta. So here mg sin theta minus Vk mg cos theta. Mg will be taken common. Sin theta minus Vk cos theta. Mm get cancelled. The main acceleration of the body. G of sin theta minus Vk cos theta. So this is acceleration of the body slides down along the rough inclined plane. Slides down along the rough inclined plane. But ms is equal, we know that ms is equal, we know that tan theta. ms is equal, we know that tan theta is the condition. So therefore acceleration becomes 2. A is equal to g of, from figure sin theta is equal opposite by hypotenuse, opposite ms by under root of ms square plus 1 minus vk. Cos theta means adjacent side by hypotenuse. ms square plus 1. So therefore acceleration becomes to g of ms minus vk by under root of ms square plus 1. Okay, this is acceleration of the body. This is one condition. This is one condition. In terms of coefficient of static friction and the coefficient of kinetic friction. Here, in terms of acceleration due to gravity, sin theta and cos theta. Sin theta and cos theta. So in this condition, here which is applicable to theta is equal to alpha. Theta is equal to alpha condition. Yes. Now note force required the block slides down. So this is multiplying on both sides. M. So F is equal mg sin theta minus vk cos theta. So this is force required. The block slides down along the inclined plane. This is acceleration. This is also acceleration. Now similarly, acceleration of block moves up along rough inclined plane. Rough inclined plane. Same thing now consider A block of mass M placed on the horizontal surface. Our aim is the block moves upward direction with force. Weight of the body, always we know that acts vertically downward direction. Normal force, 90 degrees to the surface. Here mg cos theta. Same thing, mg. Sin theta, your body moves out, that means frictional force. Tangentially downward direction. Moves out, that means Fk. So your result force what direction? Upward direction. And mg sin theta, frictional force downward direction. So how many forces acting? One upward force along inclined plane, two downward forces along the inclined plane. So that means your upward force is equal to downward forces. Upward force F is equal to downward forces mg sin theta plus Fk. F is equal to, we have to write MA, mg sin theta plus Vkn. Where n is equal to how much from the figure? Mg cos theta. Now substituting this value, if MA is equal to mg sin theta plus Vk mg cos theta. Mg will take common sin theta plus Vk cos theta. So your remaining get cancelled. A is equal to g of sin theta plus Vk cos theta. So this is the acceleration slides up. Or sometimes we take and consider minus of. A is equal to minus g sin theta plus Vk cos theta. So that means acceleration always downward direction, but your body moves upward direction. 90% will consider. Now force required moves up. Like this is force required moves up. Mg sin theta plus Vk cos theta. This is formula we will use. Force required, body moves upward direction. Moves upward direction. So suppose now if the surface is smooth inclined plane, inclined plane, inclined plane. Now acceleration of the block moves down, moves down. So from in this formula, like this is smooth mean the surface is smooth. Mg cos theta n mg sin theta. So here f is equal to 0. F is equal to 0. From figure n is equal to mg sin theta. Sorry, mg cos theta. N is equal to mg cos theta. So along the inclined plane upward axis, so F0, that means unbalanced force. Unbalanced force acts on the block. So therefore unbalanced force F is equal mg sin theta. Same thing, this is force required, the body moves slides down. But according to Newton's second law of motion, F is equal to ma mg sin theta. M will cancel. That means g sin theta. G sin theta. This is acceleration of the body slides down along the smooth inclined plane. Smooth inclined plane. Same thing, the force required body moves up minus mg sin theta. This is moves up. Now the acceleration is equal to minus g sin theta. Okay, g sin theta. This is along the smooth inclined plane. So now another concept to find the time of ascent and descent, to moves up or moves down. Time of descent. So time of descent, when generally we know that any body moves, so highest point to lowest point, top to ground, vertical motion, that is not a time of descent. But here time of descent means the time required, the block moves down along the rough inclined plane. Okay, top of the inclined plane to bottom of the inclined plane, and time required, the time is known as time of descent. Like this is rough inclined plane initially blocked here, to the top of inclined plane. At this point, initial velocity 0, that is moves down along the inclined plane. The distance covered by the block to reach this point is equal to L. So, a time required, body moves down. Here U is equal to 0, S is equal to L. Already we know that the acceleration of the block slides down along the inclined plane. G of sin theta minus Vk cos theta. Here, what is asking? T is equal to TD, time required. So TD is equal to question mark. From equation, S is equal to ut plus of 8 square. S is equal to the length of the inclined plane, L. So this term becomes 0, U0. Of A value, G of sin theta minus Vk cos theta. Then what is t? T is equal to TD. That means TD square. So this is already 0. Remaining L is equal to half G of sin theta minus BK cos theta into TD square. Now G of sin theta minus BK cos theta into TD square is equal to L. Now TD square is equal to sin theta minus BK cos theta. G of sin theta minus BK cos theta. So time of descent is equal to under root of 2L by G of sin theta minus BK cos theta. This is time of descent. The block slides down along the rough inclined plane. So already in the kinematics, in our straight line motion, body moves up and moves down. Time of ascent is equal to time of descent. So similarly, here also time of ascent equal to time of descent. So time of descent purpose we will consider plus is there. So next time of descent for rough inclined plane. Now time of descent for smooth inclined plane. So initially a block of mass can be here at highest point. Initial velocity how much? 0. The block slides down. TD. At the same time, here also U0 S is equal the length of the inclined plane. Acceleration is equal G of G sin theta. Next asking TD. From equation S is equal to UT plus of it square. S is equal to how much? UT plus of it square. Here U value 0. U into 0 into T. That is becomes to 0. Now L is equal of G sin theta T value TD square. Our requirement mean TD square is equal to sin theta. Therefore TD is equal okay, this is time of descent for smooth inclined plane. This is time of descent for rough inclined plane. So next we'll solving one application. So the time required to reach the body TD here, like this is rough nature. Smooth, rough. Same I in both cases. Length of the inclination, height of the inclination, or same. That is in both cases. Length is same, theta is same, height is same. Height is same. So we are condition for the time required to reach the ground on rough inclined plane is equal to n times of time required to reach the ground on smooth inclined plane. So time of descent, we know that on rough inclined plane under root of 2L by g of sin theta minus make cos theta. Here n under root of 2L by g sin theta. Okay, here question means the time required to reach the block on smooth rough inclined plane. N times of the time required to reach the smooth inclined plane. And TD is equal TD rough like this is smooth. Okay, both are time of descent. So if the say one block slides down, or time required to reach this point on top surface, TD, same body to reach downward direction. The TD is equal to n times of TD on smooth surfaces. So this is we know that 2L by g of sin theta minus bk cos theta. Here n is there. Smooth increment time of descent under root 2L by g sin theta. This is squaring on both sides. Root cancel 2L by g of sin theta minus bk cos theta. That is equal to squaring n square into 2L by g sin theta. So 2L get cancelled, GG get cancelled. So remainder 1 by sin theta minus Vk cos theta is equal to remaining n square by sin theta. Okay, n square by sin theta. So this equation cross multiplied. So 1 into sin theta. Sin theta. That is equal to n square into sin theta minus Vk cos theta. Here 1 into sin theta, 1 sin theta remaining. So n square multiplied inside the bracket sin theta into Vk cos theta. That means n square sin theta minus n square Vk cos theta. So minus value transfer left side. That means n square Vk cos theta is equal to n square sin theta. The sin theta transfer left side. Sin theta minus sin theta. Here sin theta will take common. n square minus 1. So that means Vk is equal sin theta by, so cos theta here, numerator that set transfer becomes to denominator. N square minus 1 by, here numerator, this is becomes to denominator. Sin by cos, we know that tan theta. This is we have to write 1 minus 1 by n square. So this is Vk value. Okay, now coefficient of conduction of the rough surface. So here Vk depends on theta. So theta may be 45 degrees, 30 degrees, 60 degrees, any angle. So by theta is about 45 degrees. Vk remaining 1 of Vk is equal to 1 minus 1 by n square. Okay. So coefficient of conduction depends on angle of angulation. Theta 45 degrees, this one. Theta 30 degrees means sin 30 and something. Theta 60 degrees. Okay, this is. Okay, thank you for watching. So please share, like, and subscribe my channel.